Can you understand? So it is equivalent to each layer. We will have more options. We call it high availability. High availability. And it is very safe. Because we export can do strategies accordingly. Or by the corresponding firewall. And we are more scalable. These are some of its mechanisms. Or some features are called extensibility. Why is scalable? You look at each layer. Relatively speaking, they have done so many backups. If the future is for the access layer, I want to introduce more terminals. I add another access layer device. Then connect to the original network. Because for the upper, is it all planned? Look. I'm coming in now. Just need to be between our second floor. Let's do a relative redundancy. Because the upper layers do not need to be edited. So in the future I will add a switch. More data. In other words, the access of our terminal. It is very easy to extend. That is, the more rules are built for your network, the clearer your hierarchy is. And the more regular the network deployment. You will find that this is a very good structure. Then in the future, you will expand the network as a whole. For example, your company has a new business requirement. You are now going to expand the network. It's all very, very convenient. This is basically some form of their communication. At last, let's look at the duplex mode. Take a look at the duplex mode. For our duplex mode there are two techniques. One called half duplex. A duplex. What's the difference between them? Very simple. First let's talk about half duplex. It's like a walkie-talkie from our early days. Concept of walkie-talkie. What is a walkie-talkie? At the same time I press this button and talk. I'll take up the entire channel. Others can only listen to me when I speak. The same moment. For a communication mode such as a walkie-talkie, you can't talk to two people at the same time. Don't support the two of you talking to the outside world at the same time. Half duplex is just that. For us at the same moment. It does not allow us to perform both data uploads. Data download. That's the one. Our physical transmission link. We are absolutely only at the same time. Single item data transfer in the same direction. Here's what we're talking about. Technologies such as half duplex. And in our half duplex technology, it will have a data conflict problem. Then we have an older technology called CSMACD. Carrier Sense Multiple Access Collision Detection Technology. To solve this problem. But now this technology. Basically there is no use seen. So you don't need to pay too much attention to it. We're basically hardly seeing half duplex now. Except in some extreme industrial environments. That is, in some networks less than gigabit. For example, some robotic arms. In such an environment, you can still see half duplex. Now in our overall internet data communication, half duplex has retired from the stage of history. Because its efficiency is too low. That's it. Duplex mode. Let's look down. Full duplex. As opposed to half duplex. You can see its arrow. Draws a two-way arrow. Stands for full duplex. It's like we call. What are the characteristics of calling? I can hit you at the same moment I'm talking. When you fight me, you can also talk. For example, a phone call to quarrel with someone. The two of you can argue at the same time. If it is a walkie-talkie, you just have to wait for it to finish first. Then you scold back. Wait until it finishes scolding you. And then scolding back. That is, we have more freedom of speech as a whole. For data communication. That I can upload data. Data can also be downloaded. Non-interference between the two. But please note, 2 duplex modes. It supports both upload and download. It's just that half duplex doesn't support doing 2 things at the same time. Full duplex support. Instead of saying half duplex can only support upload or only support download. First of all, you need to know this row. Then we basically this PPT. Almost finished. This is the part above. We then go down to the data encapsulation process. We actually said a lot just now. Said a lot. But specifically for the transmission of our entire data. We just talked about the 7th floor. Now I'm going to talk about what exactly I'm saying. That is to say, each of our layers can perform the function of each layer. So how to implement the function of each layer? You see what you say. Layer 2 can complete the check and have a MAC. Layer 3 has an IP. Layer 4 has a port. We will not mention the application layer of the 5th, 6th, and 7th layers for the time being. That specific port of each layer. Where is this IP address, this MAC address? Don't worry. Then we will talk about how to implement the part of our model today. That's where we are. Data in its entirety before sending. We will have a word called encapsulation of data. So what does data encapsulation mean? Like wearing clothes. Data will be found. We as an end user. This is called sender. I want to send a data to the outside world. Then before sending the data, you will see that there is a user date. We usually say, this is called business data. The future company. The whole we run carries real data transfer. We call it user or business data. I generate a data locally. Like I sent a hello on WhatsApp. Then the data I sent is actually what I want to deliver. Now comes the problem. Our device. I'm just producing a hello now. This data. If I don't go through any other. We are talking about the identity of each level. That first. My device knows the data I generate. What does hello mean? It is not known. The second hello. Who are you going to tell? Do not know. Where do you want to send this hello in the future? How to pass? If the other party does not receive. Do you need any response? I don't know all of this. What is this like? You want to send a courier outside. You're packed now. You took a piece of tape and wrapped it around. Put it here. There is none left. You thing. Neither tell anyone what courier company you choose. Don't tell anyone who your device is. Don't tell anyone where you send the courier. Then you can't send this data. Can you understand? You are equivalent to generating a character locally. You can't send this. So you want this hello. Arrive at another person. For example, your friends. Your netizen receives this hello on its computer. You have to have a transfer process. Then during transmission, we need to carry out layer by layer data encapsulation. It is equivalent to adding a layer to your data. Add another layer. To ensure that this data can eventually be via the internet to the peer device. Reach the peer device. Reach the peer application. And arrive at the overall page of the peer. And compile and display it in front of it. So the overall process. It requires all our layers to cooperate with each other. Let's not talk about the upper 3 floors. We can see that at each layer it will write L here. L means level. Add a 7-layer header. Application layer header. Add a 5 floors. That is our current presentation and session layer. We won't talk about this. after the top 3 layers are added. How big is our overall data? You'll find it's so big. You will find the original. This data is only so big. After the 3 layers of headgear are finished, it will be so big. Don't care. What does it cover? It's the various functions that I'm talking about. Next we get to the 4th floor. In 4 layers I will add a new header. It is our 4-layer header, which is the header of the transport layer. Here we will identify the port, and will identify the original port and the destination port. The 2 most important parameters are here. After the 4th floor is over, our data has become even fatter. Then go to the 3rd layer, and continue to perform encapsulation. In layer 3 we will encapsulate the source IP, destination IP. What is the IP of my device now? What is the IP of the peer device I want to reach? We'll mark it here. Equivalent to what would I fill in on the 3rd floor? Sender and recipient information. Further down, what will we fill in on the 2nd floor? Source MAC, destination MAC. When data forwarding is performed on such a link, exactly which MAC address am I from? What MAC address did it send to? We want to identify. Second, we now add a tail to the 2nd layer. This FCS is one of our frame check sequences to verify the overall integrity of the data. It is the function performed by our 2nd layer. If the future fails to pass the FCS verification, we'll drop it. Just tell everyone here. For our 2nd floor, what is the concept of this FCS? In the future, if I send the data as a whole, everyone will find. Isn't this data encapsulated layer by layer? When it was sealed to our 2nd floor. Has it been this long? Right. It's been so long overall. Then we will do the verification of the FCS we are talking about. This check is called CRC. Cyclic redundancy check. So which part does it verify? It will check this part of the whole algorithm to calculate a value and fill in the FCS field. That is equivalent to that we are now encapsulating the overall head and figured out a value and filled it in this field. What is this data for in the end? Data goes through our transmission medium, passed to the other end, to the peer. Wait a minute, we talk. The peer has a decapsulation process. Everyone first enter this FCS. We checked first. It is good. Then let's look down. How big is this packet after the overall encapsulation? We should mention in this lesson. Wait, when it comes to MTU, I will tell you about this concept. It depends on which protocol are you using for layer 2 now? In the 2nd layer, the more standard we are using now is Ethernet 2 frame. If you use it, our final data size is. We will talk about the last 1518 today. I'll tell you all in a while. We will refer to an MTU value and a package involving the 2nd layer. It's a length. But this actually does not require you to master. We're going to look at data unpacking next. The process of unpacking is actually corresponding to just now. We first, when the data is received from the physical layer, we compile it through the network card into a binary bit stream, code for 0101. We are about to start unpacking to the 2nd layer here. We're going to remove the head and tail of the 2nd floor. So first note here at the end, we have to check the FCS again. That is CRC, cyclic redundancy check. We will calculate again. Use this algorithm to calculate all the previous data. Generate a value. After calculating this value, do a comparison with this FCS I received. If the comparison result is successful, prove that my data is error-free. during the intermediate transfer process. Then I will do the up delivery. Perform the next round of decapsulation. Guys, this is an algorithm we call it. That is on the second floor. We can verify data integrity. If the data now finds out what it says to us. Reach the peer. When the peer end encapsulation is unpacked to the second layer. Find data errors. Then I will directly lose the packet. And will not process it downward. You must know this. This is what we call this. Okay. Let's go on. We have finished the first and last floor of our second floor. We're going to look up for 3 layers. We are still going to continue to decapsulate. We're going to take off the 3-layer header now. Continue to the 4th floor. For the 4th layer, remove the head of the 4th layer. 5-level solution. 6-level solution. The final 7-layer encapsulation is completed. We can reveal the most original data content. Can you understand what I mean? Classmates. So for our current overall data, we are now complete with all 7 layers of encapsulation. We can only see user data when we reach the peer. Then all of our packages, all just for the future in transit, can help data. Just a means to reach the destination smoothly. This is called data encapsulation and decapsulation. This is our point.